And I realized that nothing in my education taught me about how to, or even mentioned the relationship between health and the built space. And there was not a lot of information out there. And because of that, I wrote the first edition of Prescriptions for a Healthier House with my co-authors, um, 26, 27 years ago. And once we wrote a book, we got a lot of clients and consultants for people who had been made ill by the environment. So we kept learning and learning and learning. And what you see is the fourth edition, which just came out a couple, 3 years ago. And the first one, the little one on the top, has big print, and the final one is 400 pages long with little print. And we, although designing buildings has always been my first love as an architect, we opened a consultancy arm to our practice. My practice is now taken over by two junior partners, so there's still a resource for you at econestarchitecture.com if people are interested. Um, so over the years, there's three major things that people called us for. People were affected in three major ways. They were affected by chemicals in their environment, VOCs, SVOCs, harder to trace, mold, and man-made electromagnetic radiation. So what I realize after all these years is that architects, we should also take the Hippocratic Oath when we become architects to first do no harm. How do we do that? Well, we choose all ingredients with the most benign chemical composition available, build in resiliency against mold, and avoid electromagnetic pollution generation in homes and shield from external sources. So I'm going to talk about each of these briefly. Chemicals. So you might be, we aren't trained as chemists, and yet to really do the research we need to pick the most benign ingredients, we need to know about chemistry. And what's interesting is that all of the functions and services delivered by living systems found in nature are a result of the use of these 12 chemicals in the periodic table. And these chemicals have a history of serving us for the last 3.5 billion years. That's quite a track record until about, maybe 150 years ago. Now we have about 85,000 man-made chemicals approved for commerce, derived from roughly 88 of the elements found in the periodic table. And we know very little about them, to be honest. In fact, we've created a veritable Pandora's box. But don't worry. Well, first of all, you should know that in 1976, the EPA created the Toxic Substance Control Act, and 62,000 of the chemicals were automatically grandfathered into the national database with no testing. But they now have a mandate to test them as of 2016, if things don't change. And they can test approximately 16 a year, which means that in another 3,875 years, we'll know what we've done. So we know that you can take two man-made chemicals and combine them and get something deadly. So if you look in many people's cleaning closets, you'll find both Clorox and ammonia. And when you mix those two together, you get nerve gas, and readily available. We know almost nothing about the thousands of chemicals we've combined into our environment. So how do we decide what makes it healthy? Well, when I started, uh, nothing advertises being healthy because no one cared. And now everything advertises as being healthy. There's such a thing as greenwash, as you in the Committee on the Environment for Chicago must know of. So here are two products, both taught, advertised as being good for you, for your health. And so we have to be the discriminators for our clients who know even less than us. We have help now. Harmful chemicals are now revealed, declared, disclosed, and scored by a number of organizations. But it's complicated. Who's certifying what for what? There's not consensus among the organizations of what they should be screening for, and it takes time. Homeowners lack the skill set, and that's why we as architects need to learn them. Consumers are getting more informed, but if homes had better labels, if we taught our clients more, health-minded consumers would demand a better product than what they're getting. So here's what your clients can do. They can find out what's in it before they buy it. Sites like, because we can make all of the efforts possible to create a clean building, and then when people move in, they can destroy it almost instantly by bringing in products and practices that'll destroy their health. So what can your client do? We now have a mandate to educate our clients. So for everything they use in the house, they can find out what's in it before they buy it. Sites like Environmental Working Group are terrific for that. That's a page out of Environmental Working Group. By simply taking their shoes off, they can help the health of the house incredibly. The highest rates of pesticides in the country are found in carpets in Florida because everyone walks on the pesticides and then walks all over the carpet. And that's where the babies play. And we can build in things that help them detox from a toxic world out there, such as saunas. If I were the king and could mandate one thing, it would be the removal of wall-to-wall carpeting. And good routine cleaning can go a long way. We can prevent VOCs. SVOCs are forever chemicals that stay in the environment and only get cleaned out. They're harmful to us because they're in the dust, and good cleaning practice is a way to get rid of them besides reducing them in the construction. So new construction chemical avoidance involves, there you see a page out of our spec book. So we have a hyperlinked spec book to all of the products and guide the contractor so it's not a research project from them. They have enough on their hands to build things slightly differently. So what we can do is research and specify all product options and protocols that go to the construction so that they are the healthiest attainable for everyone, including those people who are most reluctant often, which is the people working on the buildings. They're exposed tremendously. We can design for combustion safety, separating cars and combustion sources from future occupants. We can design in climatic resilience to minimize the dependency on mechanical systems and provide mechanical air filtration. So I'm just going to talk about the three mold now for a moment. So why our homes are so mold prone? First of all, 95% of them are stick frame construction. It's very rare to have a stick frame that is not moldy on move-in date because they get rained on. They're hard to shelter and expensive. Building codes mandate vapor barriers. We have smarter options now, but the majority of buildings are built with plastic on the inside, and the majority of climates have 4 seasons. So that plastic prevents walls from drying out once they do get wet. We build with mold chow. This was my teaching buddy for 18 years, Steve Collette, who did home inspections. And everything you're looking at there was the result of a water heater breaking while the owners were absent. And within a couple of weeks, the entire building looked like this. It was actually an insurance teardown. We use standard plastic finishes in our buildings that trap moisture. And when you trap moisture behind plastic, mold happens. A huge percentage of our homes are centrally heated with a furnace and ductwork to distribute it. And once the home becomes moldy in one area, the ductwork does a great job of distributing it throughout the house, and ductwork, if it's not maintained, becomes a trap for dust, which becomes just add moisture and you've got moldy ductwork. Huge problem. Homeowners can do several things to prevent, once we equip them with a good home, they can do several things to prevent water loss events, which is half of why people come to us because they're sick from mold. They had a flood of some type. The water heater broke and they have a crawl space and no one was monitoring the crawl space. And when someone finally went down there, it was covered in mold. These, we hear these stories. I've heard them hundreds of times now. Well, one thing you can do, a homeowner can do, is get water loss detectors and shut-off devices, and we specify them for all of our buildings. Sink liners, homeowners who don't go around and inspect under their sinks. It's not if the plumbing is going to leak, it's when. And when it does, and if you're not looking, is it going to cause mold or do you have some protection? Water heater pan. So you can fit a water heater with a pan so that when, not if, but when it does break, it doesn't cause mold. They also have better appliances now. So you can buy dishwashers, for example, that have built-in flood protection and will shut themselves off as soon as any water is detected in the wrong place. If a homeowner suspects they're sick from mold, professional testing is the way to go. And there are many different, there's a lot of nuances about how to test for mold and what to look for. And if you, as an architect, are educated in the generalities of that, you can save these homeowners thousands and thousands of dollars that can be put towards correcting the problem. So here are some of the things we have done for new mold construction prevention that are in our specifications. We introduced building protocols that protect the building and its components against moisture during construction. Again, difficult to do with stick frame construction, but you can specify that it be dried out after and remediated before any insulation or finishes are put in it. Design buildings to manage the climate naturally. We'll talk more about that later. Create a watertight envelope and direct water away from it. Build in resiliency to prevent condensation. Create hydric buffering, airtightness, insulation, etc. All of the good things that building science has taught us over the years. Dry out new wet buildings from wet construction processes. This is often overlooked and most often not specified for residential homes and the cause of several mold events. Avoid building products that are a ready source of mold food. We have not built a stick frame home or designed a stick frame home in my own practice for the last 30 years I was in it, but we do consulting on a lot of stick frame buildings. And we will specify, for example, paperless drywall, especially in areas like bathrooms that are prone to mold. Build in safeguards within the building to minimize damage from inevitable eventual water loss events like the ones I showed in the previous slides. So electromagnetic radiation. You won't find any information on electromagnetic radiation or its harmful health effects in any of the green building scorecards that we've created within the industry. It is perhaps the fastest growing unregulated health threat. We get the phone calls. In my office, we would get 10 new calls a week from people who were suffering. At first, it was just chemicals. As that has gotten better, mold and electromagnetic radiation have taken the forefront. And it is an elephant in the room. Is there really an issue? because I'm a building biologist, I attend all the conferences. It's not my thing. I know who to call, and I know the basics, and our specifications in my book have the basics. So what architects need to specify to safeguard their clients' health. It doesn't go into what people need to do if they get someone who's really suffering and is already sensitized. That's much more complex. But is it really an issue? You would think it isn't. I don't know how many of you have heard of it. It would be interesting to know after the lecture. It could be seen, though. Martin Paul gave us a lecture at one of our conferences. He's a professor emeritus of biochemistry and basic medical services for Washington State University and spent a good deal of his life um, running tests and experiments on this problem. And he says, his conclusion, it can be seen that low-level EMF exposure attack each of the four things we often value most as individuals and as a species: our health, our brain function, the integrity of our genomes, our ability to produce healthy offspring. Pretty sobering. So what can homeowners do? They can commit to a hardwired lifestyle at home and, providing Ethernet outlets and Ethernet connections. It's a lot more stable. And then we have a way to feed our technology without being Wi-Fi dependent. If someone can do nothing else, they can at least sleep in electromagnetic radiation-free zone. Our hours at night when we're sleeping are when we do our cellular repair. So this is simple. We can turn off the electricity to the bedroom and measure it to make sure it's safe, and have an electromagnetic radiation survey done on the home. Homes have different kinds of problems. The Building Biology Institute has done a very, very good job at training electromagnetic radiation specialists since its introduction into this country in the late 80s, when absolutely no one was talking about this and we didn't even have internet yet. So if you are an architect specifying new construction, the first thing you can do is have a specialist survey the site prior to construction to determine shielding requirements. This is simple instrumentations and something any architect can learn to do as well. Specify building integrated shielding if it's needed. If you've got someone, usually we only do shielding for people who are the sickest. And if they're on a site which is emitting radiation that's bothering them, then we need to call in someone to shield the building. If you are hypersensitive and you're living just about anywhere, you do have radiation coming into your building from outside sources. We can minimize electropollution from the utilities in the panel. We can specify household wiring to eliminate electromagnetic exposure to the contact to the occupant. We can specify the lowest EMR appliances and lighting, which is becoming more and more of a problem as appliances introduce smart technologies. So it'll know when you're out of bread or whatever it's doing. And as we ban the fluorescent light bulb, the only thing that was guaranteed not to emit certain frequencies, it's a whole new case-by-case rediscovery. Verify results with an EMRS with calibrated metering devices. So you can specify it all, but if a client really needs it, you need to get the home inspected after it's constructed and at various stages during the construction before things are covered up. And hardwire for a wireless-free lifestyle. At the very least, we can have bedrooms that turn off and put Ethernet in our buildings. So that's how to not cause harm. Now we get into building biology. What if we could build homes that went beyond not harming us? What if our homes could be a regenerative force where we, the people who live in the occupants, and we, the larger community are deeply nurtured at every stage of its building's life, from its acquisition of the building materials through its construction and in habitation and beyond its service lifetime. So what if through the whole life cycle of everything we care about, we could do better? We could build buildings that nurtured. I love this think tank. They're in Santa Fe, New Mexico, and I quote this quote from Regenesis in every talk I've ever given. Green or eco-efficient design is insufficient because it misses the real potential that arises out of the human presence on the planet. The possibility of organizing human activities so that they continually feed and are fed by the living systems within which they occur. It's not enough to aspire to mitigate the effects of human activity. People need to take their place again as part of nature. This is completely in alignment with the ethos of building biology. So from not harmful to health enhancing, building biology sees nature as the gold standard for human health and model for ecological balance. The physics of how homes work, how buildings work, is very complex. But according to Anton Schneider, one of the founders of building biology in Germany, the solution is simple. A home will serve your health to the degree that natural unprocessed materials are used to create it. So building science came about because buildings were failing in this country the way we were building. I mean, post-World War II construction has been an experiment, and it's been an experiment produced by building material manufacturers, by mass production. And essentially, building science did us a huge favor by studying the house as a system, because where our buildings began to fail was at the joints, where two trades we no longer had master builders. And trades would come in, trades would come out. If someone's putting the vapor barrier on and saw that some of the insulation was missing, not their job to report it. So the idea of seeing the building as a system that worked together, mitigating the forces of nature and inputting fossil fuels and supposedly clean water and outputting our bio waste, electromagnetic pollution, our polluted water, and our fumes to create better functioning building envelopes that don't fail. If you take that same diagram, green building, I would say is trying to achieve house as a better system so that the input, but still based on house as a system for the most part. And the idea is to reduce the input of fossil fuels and water and the pollution from our output to some magical point where we will then be living sustainably. And our buildings will not be causing harm at a rate greater than the natural environment can handle. Building biology has a different paradigm. It sees the house as an organism and asks, how can we mitigate or ameliorate the vicissitudes of nature and still bring those health qualities into it and as be citizens in what we output as well. So be a part of that system. How can our homes help us to be part of the natural system? In the European context, this is not as big a news in Europe as it is to us North Americans because they're surrounded by buildings. Cornwall, England, this Cobb building, 460 years old. Rhone Valley, France, rammed earth, 250 years old. Limburg on the Lawn, 650-year-old wattle and daub timber frames that are loved maintained, and still in action. Compare that to our homes, which are in need of serious renovation by the time their 30-year mortgage is running out. It's a different mindset about how to build. So what do all those buildings have in common? Clay. Clay has an unparalleled hydric buffering capacity. I remember being at a conference, long time ago. I was a speaker about natural building, and Joe Stiebrick was the spokesperson, rightfully so, of building science, and he talked about hydric buffering capacity for the first time. And through his talk, I now understood what the heck the Germans were talking about in their literature, but they were talking about an unparalleled amount of hydric buffering capacity, so much that these old buildings had flow-through wall systems. They didn't require any kind of barrier because they could handle everything in terms of water that the atmosphere was throwing at it. And clay has a 15,000-year history of successful building use and craftsmanship. So building biology, along lines with seeing our home as nature's the gold standard, sees our home as our third skin, a dynamic interface. So how does our second skin is our clothing. Our first skin is our skin. It's the largest organ in our body. Our skin shape shifts as the external environment changes, insulating us from cold and cooling us from heat. So you wouldn't do this except on the very, very most challenging days of parenting. I know they come up. And we don't have to do this. They don't do it in Europe. So there are 25 principles of building biology. And if we distill them down to the type of building we would want to create, we want natural mass wall construction that's vapor open, high hydric buffering capacity, energy efficient, low embodied energy. We want natural indoor climate control through passive design strategies and radiant heating. We want this because when you combine radiant heating and thermal mass as the main heat source, you create ion balance, healthy humidity levels, comfort, lower man-made electromagnetic radiation, and low embodied energy. We want natural daylighting and air exchange. We want the daylighting to be diffuse, multi-directional, operable, shadable, and site-specific. I'm not, we're not against technology, but what about when the power goes down? Natural, non-toxic materials, finishes, and furnishings. They should have a pleasant smell, be hygroscopic in and of themselves. They should create a balanced, subtle electroclimate, that is the DC climate, direct current, be sorptive, have sorptive acoustics, and color and pattern per nature. And we should have a natural electroclimate that's as close to the natural direct current levels as possible, avoiding geopathic stress, and wired for AC safety, as I've mentioned. So mass wall construction, what's available now here in North America that has mass and insulation, is non-toxic, has exceptional hydric buffering capacity, vapor open, EMR blocking capability. Zafira, I realize I don't have any clock to look at while I'm doing this. If you can tell me when I've got like 5 minutes left, I will talk fast.
Okay.
These are all methods I've either had the opportunity of working with, or there's a couple that I've drawn but didn't materialize. But they're all available depending on where you are in the country. Adobe, compressed earth block, available even in Chicago. Rammed earth, light straw clay, which is what I spent a great deal of my career working on. Hempcrete, which I think is a marvelous kind of newer version. Wood insulated concrete forms available and usable, made in Ontario, Canada, made in Oregon. And AAC, aerated autoclave concrete, very popular in Europe, Japan, India, everywhere else I've traveled, and available in a few places here. All of these have the qualities. And then pegged laminated timber, wonderful material, again, available through Holtz 100 in Ontario, Canada. And it has all of these qualities. So just some of the work my firm has done, natural mass wall adobe in Santa Fe, where I cut my teeth as an architect. These were not considered mud huts by any means. If a home was real adobe, people understood the quality and the feel of it, and it demanded more on the real estate market. So brick by 40-pound brick, the homes went up. And here's some of the finished homes that we were responsible for designing. So you can see these aren't mud huts. These are high-end homes with a high degree of craftsmanship. Light straw clay. In the time my husband and I worked together, Lou worked with Robert before I lassoed him and came to Santa Fe, but we have worked in 17 states, 5 provinces, and done over 60 homes. It's probably over 100 homes built with the light straw clay method. And I worked with a team of people, including Lou, to get it into the International Residential Code. And Robert and I had the privilege of writing 2 books about the work we have done with light straw clay. This was the first home we built for ourselves in Santa Fe in 1999. And this is the home we currently live in Ashland. We didn't change a whole lot in the formula. We did small refinements over the years. We built for ourselves about 5 times. We've lived in this home for 14 years now, and it's the longest either of us have lived in a single place. So natural indoor climate control. How nature does climate. Think of the sun and the earth. It's radiant heat, and it's stored in thermal mass. If we were to spray the surface of the earth with foam insulation, humanity would not survive.
Paula, if you want to have a 15-minute conversation, you've got 5 minutes. I'm thinking you should probably just have a 10-minute conversation and I can chime back in. You can talk for 10 more. Up to you.
Okay, I'll do it as fast as I can, but I know I can do it in 10. So you'd have a 2-degree temperature variation from head to foot like nature. There's no temperature monotony zones. We're talking about nature at its best, not nature in the Sahara Desert or places where we probably wouldn't want to live. It's quiet, maintains healthy humidity. In other words, it doesn't blow air around to dry it in good climates. There's no ion depletion in good places in nature. There's no fried dust. And there's minimal air velocity when it's used for heating. And we maximize air velocity for cooling. Minimum energy put. No fossil fuels are burned to make the planet, and make us able to live on it. So forced air conditioning in North America is through traditional furnaces now, because mini splits are becoming popular, air-to-air is becoming popular, still contributes to 71 to 51% of our homes in North America. And how does it compare to nature? Well, it's inefficient. It heats air. It's convection. Air is an insulator, so this is not efficient. The air becomes too dry. It's uneven. It's too hot, too cold. It's noisy. It creates ion depletion. Negative ions will cling to ductwork. And so our air becomes a Santa Ana condition type ion count. Furnaces fry dust, which especially nowadays with all of the SVOCs is a serious toxin. ductwork, as we mentioned, often distributes dust and mold. So the best solution is to get as much as we can from passive heating and cooling. Here you see on an Econest a sun bump on the outside and on the inside. So we have deep shading around our buildings to protect the natural wall system, large roof overhangs, and then we pop out with pretty invulnerable materials where we want to collect on the south. Passive winter heat gain. We build in thermal storage capacity. It's really easy in Santa Fe, where you have great diurnal swings and sunny winters and access to thermal materials, but they work in every climate if they're used properly. This is our, we had to build a shear wall because we're in earthquake country, and this is how we did it. You see on the left, we have crossed beams per our engineer's instructions and then filled the wall in with wattle and daub construction so that when the sun shines on it, on this side, it warms the bedroom on the other side. The masonry heater, so radiant heat. Building biology talks about the Kachel oven as the, in the original material. I didn't know what it was, but I knew I wanted one, and here's how it works. That's a finished model. It weighs several thousand pounds, and the wall around it, in this case, is adobe for added thermal mass. And what it will create is the ideal conditions for building biology, less than a 2-degree temperature variation from head to foot at its source. There's no temperature monotony. If you're too hot, you move further away. It's quiet. It maintains healthy humidity. In other words, it doesn't dry the air out. There's no ion depletion because it doesn't get, there's nothing for the ions to cling to. In fact, soapstone will emit negative ions into the air. There's no fried dust. As I said, it doesn't get hot. And there's no blowing air because it's a radiant source. So how well does it work? In Santa Fe, we heated the entire house with this except for the bathroom zones. This is the adobe wall on the other side of it. And this is that wall with thermal photography while the fire was burning, and then 10 hours later after the fire was out. And you see it's just reaching its prime of heat at that time. The next morning, we would light another fire. 24 hours later, the whole mass would still be warm, and do it again. I was really disappointed that we couldn't get a LEED rating for this house because we couldn't get the basic Energy Star rating because we didn't have an efficient air conditioner because we didn't need air conditioning. Natural daylighting, building biology, ideal, multi-directional, diffuse, no glare, tracing the sun and moon, natural ventilation. So even if we have an HRV, we have one. I don't know its worth in our house because we have cross ventilation provided in all of the rooms. It's a design feature. Make it abundant, operable, shadable, site dependent, natural and non-toxic finishes. Here you see an adobe home we did in a very hot part of Santa Fe. Hygroscopic regulation of healthy humidity. If you have clay on your walls, what we do now, we make our bathrooms really wet and we suck all the air out so that we won't get mold. And then the rest of the house is getting dried by furnace heat. And so it's unhealthy conditions. We want balanced, abundant ionization, serene acoustics. If the walls are sorptive materials like clay, they will absorb sound and there's no echo. Pleasant, neutral smell. Color and pattern in accordance with nature. Balanced DC electroclimate and earth coupled. In this case, it's an earth floor. So the complex, it has building for health. The physics is complex, but using natural materials is a simple solution. So sight, sound, touch per nature by using nature's offerings. Our 5 senses common sense. So I always make the parallel of food and housing, food and shelter, because the statement that there's almost always a direct correlation between the biological compatibility and ecological performance holds true for both. On the left, we have um, junk food. Sorry if I'm offending anyone, but that is high environmental cost. God knows what those chickens went through, what it's breaded in, what kind of oil it's fried in, and where the container is going. The wax line container is going to go once the person is finished, and we know that it's not the best thing for our health. On the right, kimchi ingredients grown in my backyard, and you can see that it's sensuous. So, sight, color, and pattern in accordance with nature. I never understood this until I had a client with parrots, and she built a house around her parrots. Long story, but parrots cannot be around machine-made goods, or they have suffer from mental illness and die. So what does that mean? They need a natural environment, and maybe the parrots are our canary in the mine shaft. So color, not like this. Even though we resort to natural names, I'm sorry I don't know what a wenge or a new age is, but you always see Starry Night, Savannah Green, Raspberry Blush, North Sea Green. We give natural names to things, but they're not natural, they're monotonous. And in spite of the names, a parrot would go insane if you just left them in a painted room. And pattern doesn't, machine-made pattern, this could kill a parrot. Lots of stories.
One
As
minute.
with Okay, as with sight, so with sound, humans involved in nature, where every sound was the conveyor of information essential to survival. In nature, as with the sights of nature, there's a pattern, tone, and inflection without repetition. Uh, Rhythmic, we all know what a brook sounds like, but it's not repetitive. It's like the visuals of a snowflake, never repeats. It's soothing to us physiologically and psychologically. But what do we do in our homes? We introduce meaningless, repetitive, physiologically stressful sound in all of our mechanics meant to make our lives better. We need to minimize the need for a furnace to turn on frequently, minimize the impact of the sound by using sorbent materials, etc. As with sound, so with touch. We can sense temperature, humidity, ionization, and textural aliveness by the things we touch around us. This is a foot on an earth floor. And when you walk on an earth floor, your foot doesn't sweat. A naturally sealed earth, wood, or stone floor feels and behaves very different than a plastic coated or machine made floor. It feels like the stuff we like to go barefoot on in nature. So just a quick comparison. Sorry about the graphics. The house is a system. Um, Conventional green building is technology based. Building biology sees a house as an organ or an organism. It's nature based. We defined as an industry what's green. Building biology was formulated in an interdisciplinary atmosphere with doctors, psychologists. Um, I have heard many lectures that claim that energy efficiency, in other words, air tightness and introducing mechanical air exchange will result in health. That has not been my findings. Health and ecology are integrally connected through nature. Uh, a lot of green buildings stresses state-of-the-art technology as life support. Whereas building biology stresses climate-based resilience, minimizing the dependence on technology. Um, Green building and green building scorecards use government industry standards for air exchange, chemical exposure, VOCs only, no attention to the SVOCs, and for mold safety. Building biology has introduced a precautionary principle for VOC and SVOC exposure. Electromagnetic safety, mold prevention, ion balance, subtle DC electroclimate, indoor climate standards, which are much stricter than the ones we have in any of our point systems here. Longevity with biodegradability at the end of life cycle, a history of successful use, and we'll go on. So in a world of compromise when it comes to our homes, We don't have to leave nature behind when we walk through the front door. Thank you for listening and open to any questions, and I'm free to stay as long as they'll let me. And I'll stop sharing my screen so we can get on together.
Thank you, Paula. That was great.
That was sorry guys, that was a 1.5 hour lecture, probably.
It
You
was
did a
terrific.
great job of condensing it.
Thank you.
Can I jump in with a question?
Yeah.
And just a huge thank you. This was really great to hear, and I'm dying to learn more, and I've been looking at it for a long time. But one question, since you've done a lot of homes in a lot of different places, what have you found to be what's successfully onboarding contractors who are maybe not familiar with light clay straw or whatever technology you might be building with?
So first of all, most of our impetus to build healthy in the last 15 or 20 years has come from a client. And so the client is the one who searches for the builder who she thinks can come on board. And that makes our job, we'll help interview, we'll help locate, but it makes our job easier when the builder is taking this on because that's the conditions for taking it on, that they take an interest in this. That took a lot of educating clients one by one in classrooms and educating being on hand to educate builders as they go step by step through the process if they haven't done it already. And smart builders see right away that this is a business opportunity to become one of few experts in this field.
I would like to add to that. Having interviewed Paula a few years ago, I also interviewed maybe a dozen other people that specialize in the use of light straw clay. And the majority of them were trained in Paula's workshops at Econest. So Econest's business model was to build and integrate education into it. A lot of the contractors that do light straw clay from Michigan to the Pacific Coast were trained at those workshops. And now that Paula is retired from that business, that arm of it has shrunk. There still are seminars, but there's a great need for it. And one of the reasons that I've started the Light Straw Clay Collaborative is to see how can we start the next wave of education, because there's numerous buildings I've designed of light straw clay where the client is, let's go, but I can't find a contractor locally that can do it.
Great, thank you.
I
Got a
have a question. Your examples in Santa Fe sort of work with that climate. Here in the Midwest in Chicago, heating, I mean, radiant heating seems to make sense, but cooling, I think can sometimes be a challenge. What are your recommendations? Is it just a kind of natural ventilation or a cooling system?
Well, there are some climates where natural ventilation isn't going to cut it, and you're in one of them. You're too cold in the winter and too humid in the summer. It doesn't mean you don't provide the ability, because sooner or later the power goes down, or where we are, sooner or later everything gets filled with smoke and you can't open your windows. So, understanding that cooling is necessary in some climates, air-to-air heat exchange, and especially mini splits with individualized input in individual rooms, not centrally ducted, is a healthier choice because of the tendency of ductwork to get moldy when you're running cool air through it in a hotter, humid climate.
Thanks. Makes sense.
Brian, I see your hand is up. I don't see you, but oh, there you are.
Yeah, sorry, I'm home with a sick little girl today, so it's kind of a mess over here. But echoing others, great presentation, really inspiring, and what an interesting way of framing the problem. It occurs to me, as much as your work has kind of focused on, high-end single-family homes, it seems like a lot of other archetypes truly need to be kind of working in this, in this direction. Anything I can think of, prisons, classrooms, commercial spaces, everything. I'm curious, even if you haven't worked in that realm, or maybe a little bit, how do you think we kind of begin to bridge that gap?
Yeah, I've worked in that realm a lot because many people who approach us on a consulting basis are already sick from the environment and they've already spent their money on doctors and trying to find healthy homes. So there's a saying in building biology that any improvement is worthwhile. Also, when I began to do clay straw homes with my husband Robert, I kind of left behind a very lucrative high-end kind of Adobe McMansion business in Santa Fe. And we started working with common folks, but they were driven. They had experience at workshops and and we kind of educated them along the way and they wanted it. And so a lot of them became owner builders. I know in Chicago proper, there's probably not a lot of room for owner builders, but you can make a difference by doing the things I talked about at the beginning of the presentation. You can educate yourself. There's a lot of things that you can do healthier, have no impact on the price. It's just as healthy to use a product that has no VOCs as one that has some. I hope that answered your question a little bit. It's a very long discussion.
I know it was a very open-ended question, but there are a few nuggets in there that are definitely helpful. Thank you.
Buy my book if you don't have it already,
I,
because
I'm I'm thinking that I'm gonna have to go out and get a copy. Yeah.
yeah.
All right, we're at time. If people want to hang around and continue to ask questions, that's totally good. I just wanted to, before people start to depart, thank Paula for joining us today and an amazing presentation. And also thanks to our members of FIRO for connecting us to Paula in the first place. And thanks to everybody for coming. Um, any other questions, keep throwing them out there. Just wanted to get the thank yous out of the way. Thanks, Paula.
I just want to say before everyone leaves too, if you haven't had the pleasure of feeling what it's like to be in a building that uses these principles and you're passing by Ashland, Oregon, just look us up, call us up. I'm always happy to meet fellow architects and show them what we've done.
I'd like to add a comment for Brian's question. I don't know if you're still around, Brian, but one architect that does work locally, Lou Host Jablonski, also works with light straw clay and has a number of different systems for addressing or at least reducing the need for mechanical cooling in our climate. He's out of Madison, Wisconsin. And what I can do through Daniel is share one of the videos on YouTube that he shows of constructing a house like that, where he talks about some of those strategies.
Wonderful.
That'd be great. Thank you.
Paul, I had a quick question on the strategies to reduce the EMR in your household. I had read or heard it somewhere that crossing wires can create, so if you have two conduits at that intersection, that creates a radiation point. Is that correct? Is that it's as simple as
Yeah.
just not crossing wires in a lot of instances?
So used to be when I started before Wi-Fi, when I first got involved in this, the biggest thing that was making people sick was wiring errors. If a home is truly wired per code, it's designed to avoid net current, which is the same as magnetic field. And that's a harmful field. But if you went through with a simple Gauss meter, which is a cheap instrument you can buy on Amazon, you would find where there's elevated magnetic fields. And some of that is due to wiring error, especially ganging three-way switches and all of this stuff I learned nothing about in architecture school. Again, the basics are in my book, but if you have further interest, the Building Biology Institute has great educational programs.
Thanks.
But for your clients, urge them to get a survey done especially if they seem to be symptomatic of what's going on in their house. Anyone have any other questions for me that I can answer?
I have a final one. I learned a bit about some of these topics when a couple potential clients approached, because they had homes that had made them sick. And one thing I learned along the way, or I thought I did, and I'm curious your thoughts on this, is that once somebody really gets sick, they can be very easily triggered by what might not bother somebody else. And so getting into a healthier space where they can reclaim their health seemed like something that had to happen. So I guess what I'm wondering is like, first of all, do you find that true that some people are just they're hypersensitive because they've been attacked or their bodies got to a tipping point, and two, is that kind of can you really build a building with the stuff that we have around us today, you know, that is going to provide that kind of haven?
Yeah, it can be done. And we have done it several times because it was our specialty. My advice to any architect who wants to do it is, first of all, hire a team of consultants who know what they're doing, at least for the first one. And it's all about expectations too, because a lot of people who are, yes, it's true, people who have been exposed to chemicals, magnetic radiation, or mold can all exhibit hyper reactions like sears, like chronic inflammation or whatever, when they're exposed to minute amounts, and that makes it very tricky. What makes it doubly tricky is the world is not a safe place for them, and they're sick now, and they don't trust anyone. And so that is not a good formula for a successful architect-client relationship for starters. The first thing I tell people is building you a house that's 99% healthier than anything else that you're going to come across is a piece of cake. Building something that's going to be 100% perfect is very difficult to do. You need to become a responsible member of the team. And here are some houses we've done. We have this advantage that you can, the owners will let you in and you can go and sit in them. And if you feel okay, because most people know right away, if you are okay in that building, then we have a basic starting point for you. I don't try to do straw bale, straw clay, or any natural, especially a natural wet system for anyone who's got sensitivities to that degree. I stick with almost exclusively fast wall, wood insulated concrete forms, or aerated autoclave concrete because they're inert and they give the client psychological comfort. There's not the same kind of wet processes. And, you know, one thing I teach my students is if someone's having a heart attack, you don't take them to a health spa. But if you want to be vibrantly healthy, you don't go to ICU. And that's how it is, you know, sick clients, or the most fun clients to work with, of course, are people who have lots of money and know that they want, you know, they're already buying organic food and working out with their personal workout guy, and why not have the healthiest building they possibly can? Then it's fun.
Thank you. Yeah, the one client, it just never, the project never materialized. I think she was definitely gun shy, and I can totally understand why. But yeah,
Yeah, it's difficult.
yeah,
Totally admit that. But it's really rewarding when you see someone get better
yeah.
because of their home.
Oh yeah.
It's a very rewarding feeling. Great. I don't see any other questions. Is there anyone who's really, really shy? Okay.
All
Thanks
right,
again.
thanks again. We really appreciate it, Paula. Thanks,
You're
Thank you,
so
Paula.
welcome.
Thank
Thanks,
you.
Safira, for
Thank
thinking of
you.
this.
Thank you very much.
I'm so glad you were
Thanks.
available.
Bye.
Goodbye, everyone.
Bye.
Thanks.